Bienvenidos, Ushamdi, and welcome to this HUT8 networking techtorial on MPLS Layer 3 VPNs. In this video, the fifth in our series on MPLS Layer 3 VPNs, we're going to be taking a look at the PE to CE peering. And specifically, we're going to be setting it up with eBGP, which is by far one of the easiest routing protocols to use. So let's go ahead and take a look at what we've covered so far. We've got our service provider core configuration done, the LDP configuration is done, the VRF configuration is done, multi-protocol BGP and that VPN v4 address family, that peering between the provider edge routers is set up. And now we're going to be ready to configure customer A in Santa Rosa, California and Chicoteague Island, Virginia, so that they can communicate over the service provider cloud and that they've got full reachability. So let's go ahead and dive in on the command line and let's make that happen. So here we are on router 3, provider edge router 1. Now, I could do the customer edge side first, right? Or I could do the provider edge side first. So let's go ahead and do the PE first because this is going to be a little more work required. So we'll go from user exec to privilege exec in the global config. And I'm going to say router BGP 1. Now, remember, if I say do show run section router BGP, this is going to show me the current BGP configuration. You'll notice that we've got that VPN v4 address family set up. Now, how am I going to peer with the customer edge router? Well, remember that we've dropped that customer into a VRF. Customer, it's CUST-A is the VRF that they're in. So when we go to configure BGP, we have to do the exact same thing. We've got to put them into a VRF because we don't want their information in the VPN v4 address family. We certainly don't want it in our IPv4 unicast address family. Where we want it is in the address family for IPv4 address family for, and I'm missing my, IPv4, got the order messed up there, for VRF customer A, right? So it's an IPv4 address family peering, but it's in the VRF customer A. And that's going to keep it segregated from all of the other routing information, including the other customers and the global routing table and the VPN v4 routing information that's already on this provider edge router. And so from here, let's go ahead and put our neighbor statement in just like we would for a normal IBG or a normal eBGP peering. So 198.51.13.1 and the remote AS, we haven't worked that out yet. Well, let's just say it's going to be 65432. We'll give it a private autonomous system number. And then we're going to come back and there's a number of things we could do here, right? We could put a password on here in order to secure the peering. And I'm going to leave the password off for now. But as of right now, what we have right here, this is enough to stand this peering up. So it's time to go to the customer edge side of the house. So here we are. We haven't dealt with the customer edge side. We've got like a chalkboard look here. So here's router 1 customer A. Let's go ahead and go into privilege exec and then into global config. I'm going to say router BGP 65432 because that's the autonomous system number we're going to use over here on the customer side. Now, I'm going to go old school. We're not going to do the address family configuration here. I'm just going to go old school. We're going to say neighbor 198.51.13.3 remote autonomous system number 1. Now, this is going to bring the peering up. But what I really want to do is I want to say network 1111 with the mask of all 255s because I want to advertise that NLRI. Now, remember, when we look back over here at our diagram, and let me pull my drawing tool up here real briefly. Where's ink to go? So remember, the way that this is going to work is we're advertising this NLRI, the 1111, into the customer A VRF. And it's in that VRF that we have a, oops, sorry, I went too far there, a route distinguisher that will be prepended to the IP 1111. And it's in that VRF table where that route distinguisher is prepended to this route. because this is going to keep it unique so that when the VPN v4 address family advertises that NLRI over to router 5 in the BGP update, it could be that router 2 had a 1111, but they're different because of the route distinguisher. Remember, the only purpose of that route distinguisher is to make the NLRI that's being received into that VRF unique in the VPN v4 BGP updates that are being sent between the PE routers. That's how it works, and it works both ways, right? From from PE1 to PE2 and from PE2 to PE1. That is how this is going to work. So let's clear our screen here and let's get control of the mouse one more time. And so we've made that advertisement. Well, let me ask you this. If I was to say show, and I'll do old school here, so we'll say show IP BGP neighbors 198.51.13.3 advertised routes. Now, this is going to show me what router 1 is advertising to his brand new eBGP peer, show IP BGP summary. Again, old school command there, non-address family. And you can see we've got a peering that's up. I'm advertising this 1111. So now let's go over to the provider edge router. How is this going to work on the provider edge router? Well, if I say show IP BGP summary, there's no peering. Well, what if I say show IP BGP neighbors 198.51.13.1? What am I going to see? Yeah, you're right. The answer's nothing. There's no such neighbor because we've done this in a VRF. And so now, again, we've got this other syntax we have to take a look at. So we're going to say show BGP. And again, the VRF name is right up front, customer A, all, and let's try summary. Aha! This is where I'm seeing that information, right? And you can see here prefixes received is 1. And it just so happens that that prefix, if I was to say 1111/32, BGP all, sorry about that, I pulled neighbors out of there, and I'm missing something here. Hold on one second. And it might be before the all, where I can drop it in. No, hold on one second. I'm actually drawing a blank here on what? Oh, I'm sorry. My bad. Wrong address family. I was thinking VPN v4. So what we need to say in order to see that information is we're going to say show BGP VPN v4 unicast all, and then if I was to say the 111/32, now we're going to get the information I wanted to see. And I apologize. I had left in the VRF and thought it was VPN v4. So now let's take a look here. Well, take a look at that address right there. This should look very similar to what we saw in our network in the diagram, right? There is our route distinguisher prepended to that IPv4 address. That's our 96-bit VPN v4 address right there. As soon as we prepend that route distinguisher, it becomes a VPN v4 address. That is what is keeping it unique between the PE routers and making sure that if multiple customers were advertising the same NLRI, the same routes, the same networks, that it wouldn't matter. Because here, it's a VPN v4 route, and it is unique because of that route distinguisher. Now let's come down and talk about VPN membership, and that is the BGP extended community, the route target. Now, the nice thing about this is we've got the provider edge router, router 3 PE1. We have the IP address in here. So if I was to go over to router 5 PE2, what would we expect to see if I said show BGP VPN v4 unicast all 1111/32? Has it been advertised over here? And yes, absolutely it's been advertised, and I need to look at that VPN v4 routing table to see, a BGP table to see it. And here it is. And this is nice, right? Because it shows me, by using the IP address of the PE router, I'm able to see which PE router I'm getting this update from, right? So again, there's that route distinguisher, making sure that it's unique once it ends up over here. Here's our autonomous system number, 65432. And so everything looks good with the setup that we have right now, except we haven't configured router 5 PE2 to work with its customer edge router for customer A. If we go back to our diagram, we're going to be looking now, our first look actually, at router 6, and we're going to be advertising the 6666/32 into that VRF for customer A, which is then going to have the route distinguisher prepended to it, and then it magically transforms into a VPN v4 address that our eBGP VPN v4 address family is going to advertise over to the other PE router. And it's going to be that BGP route target that dictates the VRF into which that traffic is going to wind up. So let's jump on to PE2, which I think we are here, and let's go into, let's go into global config. Let's get that right there. We're going to say router BGP1, and again, do show run section router BGP. Let's take a look at what we've got here. So again, very straightforward configuration. Now I'm going to say address family IPv4 VRF, and I'm going to put in, we're going to say customer A. And we need our neighbor statement just like we normally would, 198.51. It's going to be 56.6 is router A. Now the remote AS, we're going to make it 65432. And you may be thinking, hey, he's walking us into something here, and I am. So we're going to use the same autonomous system number that we used on the other side with customer A in Santa Rosa, California. We're using that same private autonomous system number. So that's all we need at this point on the PE router. That's going to be enough to establish the peering. Now, there's some other bells and whistles I could put on here. I could put the the password on here to secure it. I could configure soft reconfiguration inbound, but we're going to leave it right there for now. And now let's work our way over to router 6, customer A. And let's go from user exec to privilege exec into global config. We're going to say router BGP 65432. And I'm going to come up and I'm going to say, again, old school configuration here, non-address family. We're going to say neighbor 198.51. What would it be? 56.5 is router 5, and then remote AS is 1. Now, is this going to stand that peering up? And I'm going to get, and there it is. So now what I want to say is I want to advertise the 6.6.6.6 with a mask of all 255s or /32, and that mask has to match exactly as it's configured on that loopback address, or for any other network for that matter, or else BGP is not going to advertise it. So let's go ahead and say in here, we'll say show iBGP summary, and we should see our peering. No prefixes received. That might be a little strange, but let's continue to work through here. And yes, the intonation in my voice is telling you that something's coming. And so we don't have any prefixes received. What about show IPBGP neighbors and 198.51, 56.5? And how about, what am I advertising to that BGP neighbor, the PE router? I'm advertising the 6666/32, right? Everything looks good here, but we've got this issue. If I say show IP route BGP, I don't have any BGP routes because again, we saw we hadn't received anything. If I say show IP BGP, we have not received any routes. Remember that next hop quad zeros here and that show IP BGP output is telling me that this is locally originated. And we know that it is. It's router 6 and it's router 6's loopback. So we've got a problem. So how would I troubleshoot this? Well, all right, so the first thing that we're going to do is we're not getting the BGP update. So maybe if I was to say debug IP BGP, and we're going to do updates, and I think updates is all we'll need to do. So let's kick off a debug here on BGP. Now, I'm going to come all the way back over to Santa Rosa, California here, and we're going to go ahead and re-advertise, or not re-advertise, we're going to create a new loopback address. So if I say do show IP interface brief, and here's where I'm going to add in this loopback 192. Right, and the reason I've got this set up is on router 2 for customer Z, we also have the exact same loopback address configured, and that's to show that the route distinguishers are there to provide uniqueness. So let's go into router BGP 65432, and let's issue a network statement here for the 192.168.99. And I am now wondering, do show run interface loopback 192? I think it's a 24. It is. All right. So network 192.168.99.0 with a mask of /24. So we're going to make that advertisement. Now, if I come over here to router 6, you see it lit up with a little blue yield sign right there, which means we've got some output. So let's take a look. And there it is. Denied due to AS path contains our own AS. So there's a couple of things I could do here. I could do an AS override on the provider edge router, or from the customer side, I could deal with this by simply allow AS in. So let's do that on the customer side. So here we are on router 1. I'm simply going to go ahead and say neighbor is 198.51.13.3, allow AS in. And that's all I need to do. And I need to do the same thing to allow that to happen over here. So we're going to come into router BGP 65432, and we're saying it's okay if we see our own autonomous system number. So neighbor 198.51.56.5 and allow AS in. So now, and you can see we've got the debug going here, so take a look. We've now got some routes that have been installed in customer A's global routing table. So show IP BGP, we should now see that NLRI coming across from Santa Rosa, California, all the way to Chickateague Island, Virginia, and there it is right there. And the AS path has our own AS in there, but we said we're going to allow that we're okay with that. Let's validate over here on this side, show IP BGP. And take a look at that. Everything looks great. I'm picking up the 6666. So now let's test reachability. What if I simply say ping 6666? Is that going to work? And the answer is no, it's not going to work. So I kind of walked you into the duplicate AS scenario, and now we've got the ping command isn't working. Well, remember, and this is something that's often overlooked, is when you run ping, by default, what is the source IP address in those packets going to be? Yeah, it's going to be the outgoing interface. In our case, that's going to be gig, I believe it's 01. But what's the IP address on gig 01? It's 198.51.13.1. And is that being advertised down here to PE1 so that it can advertise it as a VPN v4 prefix over to router 5 PE2 so that it would then end up over on router 6? And the answer to that is no. But it's not an issue because all we have to do is source it from an interface that router 6 does see, or an IP address that router 6 does see, and that would be either loopback 192 or it would be loopback 0, the 1111. And we've got connectivity. Let's go over to router 6, and if it worked from router 1, we should not have an issue here to say ping 1111, and we'll source it from our loopback 0 address. And it worked just fine. And now what if I try to ping the 192.168.99.99, and I'm going to source it from my loopback 0 address, which is the only address router 1 sees from router 6. And we've got connectivity. So let's take one last look here at show run section router BGP. And there's the BGP configuration on the customer edge router. Again, very, very straightforward. And router 1 customer A, show run section, router BGP, looks just the same, right? We've got an additional network statement in there, but that's not a problem because that was in NLRI that we were advertising. All right, well, it was that straightforward. That is how you create an eBGP peering between the provider edge router and the customer edge router. And the beauty of the eBGP peering between the PE and the CE is there's no redistribution that we need to worry about, because BGP is like magic dust. It's going to take care of everything for us. So it worked out fantastic. We've got connectivity. In the next video, we're going to use eIGRP as the PE to CE routing protocol. And in the description for this video, look for the Dropbox link where you're going to be able to go and download the final configs here with the eBGP peerings between the PE and the CE routers. All right. Well, that wraps up this video tutorial using eBGP as the PE to CE routing protocol. And we had I think only a single command there that I was interested in sharing, and it was literally this command right here. And we also could take a look at the received routes or the advertised routes as well. And I'm showing you the VRF commands from the PE perspective, right? So that the provider edge router could check. And remember, the received routes, we would have to have soft reconfiguration inbound so that we could take a look at that BGP information before it was filtered in any way. All right. Well, thank you so much for watching. Again, we've got 2 videos left in the series. eIGRP is the PE to CE routing protocol, and OSPF. Hope you're enjoying everything. I hope to see you in the next video.